Appreciate that. Thank you. I'm going to have to thank you again on recording so everybody hears it. Hey, it's just what Jefferson said, guys. This is going to be interactive. You know, you motivate me to have the conversation so we can go off on tangents and talk about, you know, anything and everything technical, things that got us excited. So, what does this say? Got it. So, but I want to share my screen out over here, and I appreciate Jefferson for kicking that off and setting the stage there. So I hope everybody starts chatting over here, just like you would see inside of a YouTube video where you can chat on the side there and just add comments and put your hands up if you want me to engage in the conversation, because I'll track it, but otherwise just feel free, let it be a free-for-all. So I want to welcome everybody to what we're calling the First Principle Thinking Group. You know, when we're going to think like first principle thinkers, and let's start the conversation out with a small problem. Yeah, we'll start it out with, let me see, is my video? Okay, the host has started recording. Let me just get that out of the way. I have two computers here, so I'll be going back and forth, so you might see me spin my head around. But let's start with a problem. Let's take this problem here. In about 1.7 billion years from now, the sun is going to expand and Earth is going to explode, and human consciousness is going to be just a blip on the cosmic timeline. You know, anybody in the universe isn't going to know anything about humans. We will be a blip on that universe of time. So the question is, the problem is, how do we solve for this? How do we solve for this? That's the question. So this is kind of like and feel free to start chatting if you have the answer there. But this is what Elon Musk is going through with his thought process, and we're going to talk a lot about Elon Musk because he does a great job of, you know, engaging people to think about thinking about first principle thinking. So what's the screen share? So the answer here, in case if you guys, I'll pause here a couple seconds if you guys want to, you know, type something up here. But how do we solve that? Human consciousness is not just a blip on the radar of time. You know, it's not like, oh, there were humans there at one time, but nobody knows anything about that. How do we solve for that problem? And that's. If you guys have a bigger problem than that, I'd love to hear it, but that's a good one. We're going to be extinct someday. And how do we solve that? We're not, you know, because the sun will expand and the earth will blow up. So this is the mission that Elon Musk is on. He's trying to solve for this. This is when you listen to Elon Musk, if you read his book, if you really dive into what Elon Musk is saying, this is what he's trying to solve for. So I don't see anybody chatting there, so I'll just go ahead and tell you the answer to solve for that problem.
So actually, it's a good thing we're recording this, because then this will live forever, right?
No, it won't, because this will go away with the Earth. You know, it's right. This is so the answer is that we need to get off this planet, get out of this galaxy, expand across the universe. You know, that's the answer. So that's the mission that Elon Musk is on, and that's what he's looking to achieve. And even though we talk about 1.7 billion years from now, the reality is, at what point in time do you start for solving this problem? And you know, the answer is now. We need to start now. So I'd like for all of us to participate in this first principle thinking group into that vision, to see how do we as individuals become extraordinary and help with this mission. It's really about the way we think and solve problems, and we're all going to do it in our own way, but we need to contribute to society so this doesn't happen. You know, Elon, of course, he has the resources, and he's building out spaceships that get us to Mars, which is the stepping stone to get us to the next planet, and then out of this galaxy. So he started the process, but he didn't always have those resources. So I encourage everybody to read the book about how he got started on this mission. And he only started out with $7,000, but built PayPal and sold PayPal and so on and so forth. And yes, you could say some of it's luck, but the reality is he's still on the same mission. So as first principle thinkers, we want to start the journey to push the boundaries of technology and start thinking like that. And what the first principle thinking is, and I hope that everybody can go off and do some research on first principle thinking, it's about really...
We lost you, Michael. Can't hear you.
I'm sorry?
Yeah, we lost you. You cut out.
We lost you for a while. Yeah.
Oh, okay, my back? Okay,
Yes.
So first principle thinking is about solving the problems from the most fundamental, looking at the issues from the most fundamental problems. So this journey that we're on, this group that we're in, we will talk about first principle thinking a lot. We'll be talking about solutions. We'll be talking about products that are outside the realm of Broadcom, but maybe feed into our Broadcom solutions. We'll be talking a lot about artificial intelligence. You know, artificial intelligence is something that we had some groundbreaking, disruptive technology breakthroughs last year in 2023, and we'll go through a whole class of AI, and then we will start building out labs. Everybody here will learn how to build out an AI engine that will solve problems, whether it be, to beat a video game or to, help with their large language models inside of their solutions. So this will be hands-on journey. But what we're trying to do here is to inspire you back to the time when you got involved with technology. You know, what got you out of bed in the morning and got you excited to be a technologist and engineer that you are today in this group. You know, I was speaking with Jefferson and I'm asking, tell me about the group. And he's like, everybody here is really technical, and that's great. So what drove you? You know, for me, it was about staying up past the honeymooners and watching Star Trek and saying, wow, wouldn't that be great if we can have in the palm of our hands, you know, like something that goes beep, 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 and then we can get all the information that we want. The library is in the palm of our hands today. You know, we have our iPhones and we carry our devices, but we didn't stop there. You know, there's no line in the sand for engineers. We want to continue growing technology. So we need to find it within ourselves. What is that passion that inspired us, and bring it back to the forefront here, because we are going through some really disruptive times, and it's exciting to jump back into those disruptive times and become the leaders of what is going on here. And I know we all get a lot of questions about AI and how our products work with it. And I hope this class can help us understand the foundation as a first principle thinker of AI, so that we can easily answer all of those questions from our customers when it comes to driving opportunities. Okay, so that's what we'll be doing here. Is we'll be thinking like first principle thinkers on all of our problems, and we'll create labs and skunkworks projects, and we'll bring new ideas to the product team, and we'll make a big thing of this. And this is going to work if you guys participate and get interactive and maybe even do some of these classes with me. But the idea is to drive more thinking back to our solutions like Atomic and NetApp and AppNeta at the end of the day. So that's what we'll be doing here. So again, as Jefferson pointed out, we'll be doing some lab sessions. All of this is optional. You know, you have to have that passion to say, I want to learn about AI. I just don't want to stay within my box of, you know, understanding NetOps and AppNeta and Atomic. I want to reach outside my box. I want to expand my horizon. I want to participate in this because we're going to do something big here. I promise you that. That's my promise to you, is that we're going to do something big here. And it's going to be recognized by all, you know. So we want to participate to get excited again, bring that excitement to the forefront of, hey, we helped start this. So let's engineer the shit out of this and let's get going. So inspirational reading. Guys, let's start off. I'm going to give you a lot of recommendations. Some are more like, inclined to be a part of the group and to understand, where others, you know, if you have time, that would be great. So let's start with this inspirational reading. It's a long book, but it's a great book. It's Elon Musk's by Walter Isaacson. Elon Musk had no say in this book. It was Walter Isaacson, who also did Steve Jobs' just traveled around with Elon Musk and kind of lived with him for 2 years. And when I say lived with him, Elon Musk used to live in his factories and still does, actually. He doesn't own any houses. So read the book. He doesn't own anything. He's just trying to solve problems, and it's quite interesting to understand. We're going to talk a lot about Elon Musk and his companies because I think that will generate the juices to get us excited about technology and what we're doing here, and see what he's doing with his companies. Again, we'll be diving into AI, and from a first principle thinking, when you think about artificial intelligence, the foundation of AI is the mathematics of it. So my first request to you all is to follow what I found was very helpful, just in 3-4 short videos of this Deep Lizards AI series found here on YouTube. And again, Jefferson will be posting a lot of these links, whether it be in the task, but you'll find them, is to understand the mathematical concepts. You don't have to know how to do the math, but you should know the concepts behind how an AI engine solves an outcome and what an AI engine does. So follow these because it's going to be key for our next session. So I ask just that you just kind of like, even if you breeze through these on speed number 2, with the videos, just go through them. So when I start saying, we're going to use the Markov decision process to Q-learning tables, to use the epsilon greedy, and we're going to adjust the exploits and the explore mathematical equations to beat an AI engine. And when I say that, it sounds all complex, but if you watch the video, it becomes not only inspirational, but you learn it overnight. And then with those concepts, we'll be using AI throughout this whole class. We'll be using large language models as someone to help us, or something to help us to build out solutions. So we're going to build out an AI engine that for the lab, I'll have it beat a video game. But if you guys want to think of something else and you want to say, hey, can we do an AI engine to do this? Absolutely. Let's do it. Let's learn. Let's absorb. Because once we go out there and learn the mathematics of AI, once we understand how we built our own machine learning model to beat video games, you'll stand with your head tall anytime somebody asks you what AI is and what generative AI is and how does that relate to our products. You'll be able to easily answer these questions. And it will be our guide to expanding outside of our box and our knowledge base of the solutions. So there'll be some code challenges. Again, you don't have to code in this class. We're going to use AI engines to help code for us. So for example, I built my AI engine that beat a video game in Python, and it took me, I guess, a day or two to build it out after going troubleshooting all the error code. But at the end of the day, it beat the video game. To beat the video game and have the program, the bot run, it took about 3 days. But then I also told it to explain to me exactly how you beat the video game and what you did and what were the outcomes and what paths you took. So it was pretty exciting. And within a week, I'm like, oh, AI, I get it. What next? Let's go. We'll do hackathons. There's actually official hackathons throughout Broadcom. I think we can beat them all. I think this team right here can beat them all. We have some ideas we'll put out there. We'll come together. We'll focus, and we'll be in first place on the hackathon the next time it comes around, as well as doing our own mini hackathons. We'll have debate discussions. We'll discuss. There are a lot of large language models out there. Let's have a discussion right now. Everybody, using your chat over here, I want you to tell me, do you use an AI engine, a large language model, I should say, a large language model today, and how often do you use it? So put this in. So tell me what your large language model is, if you use any at all, how often you use it. I'm interested in hearing right now, if you guys can start typing in that chat box, what it is that you use on a day-to-day for maybe a large language model. We'll start with that, not just AI. I won't use the AI word too much because we'll start getting down into a more fundamental way of talking about AI. So large language models. I use ChatGPT every day, or GPT for that matter as well. And we can explain the difference between ChatGPT. I don't see anybody typing. I'm going to pause here while I give you guys the type. This has to be really engaging. The question is, do you guys use large language models? You can put the word no. You can say, yes, I use it. This is how often. But please, if you don't mind, let's start typing some answers here so I know that I'm not just talking There we go. Michael Papa, no. Michael, you and I have a date. Remember, we're going to start using this stuff. So put something on my calendar here. No, not that much. Wow, really? Okay, old-fashioned. Haha, Ronald, we're going to get you out of old-fashioned. No more typing. We're going to get you into doing large language models. We're going to get you into having your own personal secretary to write up everything, to code for you, to develop things. It's really fascinating. And once you start getting into it, you won't put it down. It's a tool that you will not put down as an engineer. That's it. I'm only going to get 3 answers. I'm actually going to sit here and wait, see if I can get more of you guys to type here. What about you, Justin? Guys, come off mute. Everybody's on mute here. There we go. No. Wow. All right, that's it. Come on, guys. Let's be engaged. Let's come off mute. I want to hear everybody's breath. I'm muted. Okay.
So
all right.
I was talking to a friend of mine the other day, and he was working on a job site, and there was a goose that was injured on the job site, and one of the people there took the goose and rushed it to a vet, and on the way the goose died. True story. So what they did was he used ChatGPT to write a poem about the goose, and it was very good. It was very good. So I think I might use it for stuff like that.
So you're going to use it for creativity, maybe some songwriting. Let's do that. Let's. You know what? I have to introduce you guys to ChatGPT. I'll do it right now. I thought you guys were using this stuff every day. Let's do it. Let's go right now.
Michael, I do use it.
Who's that? I didn't see. Who's that? Ronald?
Here. Yeah. No, I just remember I use a lot Moises to separate tracks and stuff like that. Behind that, there is an AI model, right? And the other ones, I just use it for trivial stuff, like give me a list of X things that can work on Y situation or something like that.
Mike, I'm using ChatGPT. I don't know if you guys know that I have a radio show every weekend here in a local station, radio station. And to create content related to the song we are playing, and I'm using related to the history of the groups, the bands, and using ChatGPT to generate that information. Before that, I spent maybe 1 hour creating the content of the program. Right now, I'm using 5 minutes only, and I'm trying to put it in a way that I can talk about that very easily on the radio. But I'm confused because my understanding is we don't have access from Broadcom network to ChatGPT and other AIs. Is that real, or is only my problem?
Tony, type in chatgpt.com right now into your web browser and tell me if you can access it.
Okay, let me check that now.
While you're doing that, I want Mike Papa to read the first part of this poem.
Let me check, because I did that some months ago and I didn't have access to that.
Papa, you there?
Tony, I understand that we can use it, but it's not recommended for like critical business purposes,
but
something like that.
2 months ago or 3 months ago, it's for me was blocked. Was blocked because the semantic agent didn't allow me to access. It is working now, but 2 months ago, 3 months ago, it was blocked.
Yeah, you can use it.
Yeah, ChatGPT should be used as a framework for your thoughts. You know, it must be you that proofreads it and hits the submit button to executives, but it's a tool, and we're using AI and large language models even in our solutions today. Let's see what Justin's saying here. It's interesting that ChatGPT and similar solutions like Google and Microsoft and others are growing rapid pace. In tandem with the growing interest of AOD, please become familiar with AI technology policies. Okay, so no third-party artificial intelligence solutions are to be used in production. We're not using this for production, so this is good. We're using it to kind of like articulate our thoughts to each other and for experimental. So this meets right within our guidelines. We're going to be using this. However, there is no issues with the accuracy. Everybody must realize that even though you're using ChatGPT to write some document or anything, it's up to you to proofread it. It must be your thoughts at the end of the day, but it helps with the guidance, you know, of framing out and creating the framework of what it is you're trying to articulate. What else here? In addition, concerns intellectual property. Yes, we have to, again, make sure as we read our documentation, we're not taking any intellectual property, and nothing should be submitted outside. Most of this stuff I want you to use in this group. So I think that's fair game. It's allowing us for, as we see on top here, educational purposes. Until further notice, do not include either API definition generated in the AI code. They don't want our APIs to get out into the world. So maybe that's something we can be cognizant of as Broadcom legal team provides guidance. Okay, so stay within the guidelines, but guys, play with large language models every day. You know, it's a tool that will be in, it's not going away. It's something that's here, and it's a tool for us to learn from, and especially engineers. We go into labs every day and we educate ourselves. So let's get out there and learn. And please, I encourage you guys to use it every day in a very academic way. Okay, so let's get back here. So Papa, you didn't want to read your poem?
Oh, no, I'm good now. On a quiet morning, gray and still, Mike Papa walked with heavy will, a wounded goose within his care, its feathered wing beyond repair. The vet was near, just down the lane, but in the air hung silent pain. For every step, the bird grew weak, its soulful eyes began to speak. Mike felt a weight upon his chest, a silent plea, a final rest. He knew the end was drawing near, and in his heart, a rising fear. Keep going?
No, that's
Okay.
good enough. There's your poem, Mike. See, a lot of fun to use. Where am I?
You know what's funny is that Zoom just said that it sounds like I changed my language to a different language. So I don't know. Was I not speaking English to everyone?
No. Oh, for me, you were fine.
Okay.
You did a great job.
I understood.
Yeah.
Sounds good.
Okay.
It was a very sad poem, by the way. It sounded like it was going to have a very sad end in there, but let's. I'll have to read it later. Okay, so our journey with First Principle Thinking Group will be challenging, but it'll be marked with a chance of real impact. Again, that's my promise to you guys. If you guys stick with this, if you guys go through this, it will be impactful. So let's harness the power of technology and create and redefine what is possible. And let's all stop thinking of ourselves as just ordinary people, but let's think of ourselves as extraordinary people, because we are at the forefront of the best. You know, in all my years, it's been crazy with this AI, and we are at the forefront here. You know, when you think of Broadcom is the top 10 company in the world. It's got a $700 billion market cap. We're an engineering company, and you guys work for one of the best companies in the world at $700 billion with only 20,000 after the acquisition of VMware. I think that's up. Employees. It's an engineering company. And, you know, with that said, we don't have the red tape that I've experienced at other large companies with less market caps. So we have the chance to do something big here. So I encourage everybody to take a look at First Principle Thinking and, you know, go through some videos on First Principle Thinking and what it takes. Read the book on Elon Musk. Check out these videos of the foundation of AI, because it will be a hot topic. That's the one that I need for you guys to go through, is just some of the mathematical expressions that we use in AI. And the video I gave you, she does such a great job of explaining it. It just becomes, enlightening, and it's exciting. And get excited, because it is exciting. Again, you know, AI has been a breakthrough. We've been hearing about AI for years, but we've had a breakthrough last year, and that's why everyone's talking about it. No longer and you'll hear me repeat this in the next session, are we building out data centers, and we're looking for tools to shop for, like what's going to help me sniff out my network and identify the problems. We have a lot of these tools. Our goal now is to build out AI Factory and have all of our end devices become these inferences to answer and generatively. And we're going to get inspired by understanding the foundation of AI through this class. So with that said, let us go through my experience of solving for a problem through first principle thinking. So let's begin. About 4.5 years ago, I was watching a video, and this engine completely fell apart in midair. And what happened was the blade came loose inside of the engine, and it broke through the engine, and it completely fell apart. And everybody on board survived this flight. But when they investigated the flight of what the problem was, it came down to that there was a blade that was weak. It had a lot of vibration, and all that vibration, all of that data, the sensors were recording the vibration, and it was recorded, and it was put inside the black box, and it was there probably because it hit a bird like 6 flights ago, and it just became loose after a while. And this problem happens quite frequently. I started doing some research, and it's like, wow, we have so many problems today in aviation alone. And here it is that all of the data was recorded inside of the black box, and they have the data. So then the question remains, wow, if they have the data and it was recorded in the black box, why didn't they solve the problem of not, having the plane not take off? And the answer is they weren't doing data analytics fast enough on the plane. They weren't doing them from flight to flight. They weren't analyzing the data and predicting an outcome to ground that flight. So how do we solve for that? Well, the answer is that we need to do faster data analytics on these planes. So the solution that I came up with to solve for this was I worked at Verizon, and we're going to hear a lot about Verizon for the rest of this session, and that's going to be my subject. And then next session we'll get into AI, and I'll tell you about how we're solving problems. So Verizon has 5G technology, which is secure, faster, better connectivity, better security, better latency, better resiliency, blah, blah, blah. They also have MECs. A MEC is a multi-edge compute power, which is basically compute power that's butt up against the 5G network. It's the first line of defense when it comes to taking the information off of the devices, the device being the plane in this case, over to the radio access network. This is an antenna for those of you who are wondering. And then down to the MEC. The MEC is the compute power, and then the MEC goes out to the cloud or to the data center. So this is the cloud. So what if we can do faster data analytics at the airport? In other words, with 5G, we can start the dump process as it's coming in for a land-in. And we can dump the data to the MEC. And the MEC can now analyze here, since it's doing compute power, to say, hey, did you have a great flight? And this guy says, yeah, it was a great flight. This guy says, yeah, great flight. Yeah, I had a great flight. And this guy says, you know what? I didn't have a great flight. I think there was some vibration going on because the black box shows the sensors had vibration. So I think there's some vibration going on inside of my engine. So as soon as we hear that, we make an API call over to Verizon and say, hey, Verizon, this plane right here, we need to give it priority access on the network because we're going to turn on more sensors. We're going to turn on LiDAR. We're going to turn on video. We're going to turn on sound. And we're going to analyze this. And basically, we're going to put this device into debug mode. So as we put this device, this plane, into debug mode, we need more attention on the network. So at this point in time, we're going to move it from the slice, the network slice here, and I'll go through this in a second here, of I'm okay to, hey, I'm not okay, and we need to move that into a debug slice so that we can handle more data. So this is how we're going to solve for this problem. And I reached out to General Electric, who creates the engines for these planes here, and we talked to the Innovation Lab, and we first, actually, before we reached out to GE, we went ahead and we grabbed a patent for this because this was a new concept, a new idea. So I have the patent under Verizon, so my name's on this patent, how we can help them with these issues. So GE makes these engines for the commercial and the military. We reached out to them, and we explained to them that we can help with this problem, and they were very interested. They were like, yes, we've been thinking about things like this and how to solve for this problem. So let me show you from a granular level, more fundamental, of how we're going to solve that problem. So the answer is that GE was excited and was still today looking to build out some of these concepts for GE, even today. It will take a while, and I'll get through that. So what I want you to think about from a fundamental, again, a first principle thinking is you have your devices. They go over the network. This is the spectrum. This is what Verizon, again, I worked at Verizon. This is what Verizon's intellectual property is. You know, it's the packets in transition. It's not the devices. As you know, when you buy an iPhone, it's really made by Apple or Samsung, or it's not the IoT devices like GE's plane or another device. So Verizon may resell some of that, but they don't own that, so that's not their intellectual property. The radio access networks, those big antennas that you, when you're driving down the highway and you see those big white towers of 5G, they don't own them as well. Those are made by other vendors such as Nokia, Ericsson, Solona, Casa. So again, Verizon OEMs them, manages them, supports them. That's Verizon's managed service practice. But their intellectual property that nobody has access to, how the packets get from the device over to the radio access network. That's their intellectual property. Here is their packet core. The packet core is what keeps the policies of how, I should use my pen here, I apologize, I actually moved to the screen. The policies, P-O-L-I-C-I-E-S, the policies of how these devices connect to the radio access network. So the policies are, hey, are you a Verizon customer? Great, I'm going to give you access, I'm going to authenticate you, I'm going to build out a session, and I'm going to put you down a network slice. So a network slice is, I want you to think about the electromagnetic spectrum as a highway. And we can carve up the electromagnetic spectrum into different slices. We can carve it up into the slow lane, the medium lane, the fast lane, the HOV lane, and we can have the first responders lane. And while I only have 5 slices over here, I could have literally thousands of network slices, each with its own characteristics of capacity and security and latency and resiliency and bandwidth. Okay, so these are your characteristics. We have 5 tastes in our mouth: salt, acrid, sour, sweet. Anybody know the 5th one? I forgot it. Okay, guys need to drop 2-3 months ago. Semantic agent blocked some of the AI site stress. Okay, so we'll take a look at that. Yet the point is that even though we have 5 tastes in our mouth, we can really go out to great restaurants and have all different types of flavors. So same concept here. We can have different flavors of network slices. So network slices are how we define these devices, these IoT devices, to go over, to go over the network. So let's. Okay, let me go back into slide mode here. Okay, so let's take a look at the spectrum for a second here. So when you think about the electromagnetic spectrum, think of it as one string here. Oops, I'm going to get that pen up. So think of it as a string here. And this is your waves, and we can actually manipulate how these waves move in the electromagnetic spectrum. And the top can be we break everything down into binary, 1s and 0s. So the top could be our 1s and the bottoms will be our 0s. So we can actually manipulate these waves when we're receiving and sending data. So when you take a look at the electromagnetic spectrum, over here on the low ends, which you have your big waves, is your AM, FM, and your cell phones are right here. This is where your cell phones live, okay? They live in about 30 gigahertz over here. Then you have your radar, your TV remotes. This is what we're able to see, the visible spectrum, the Roy G. Biv, red, orange, yellow, green. We don't see infrared, and we don't see ultraviolet, okay? And then we have our X-rays and radioactive, and gamma rays are all the way up here. And as you get higher up here, you get into cosmetic rays and so forth. And all of this is, again, at the fundamental point of first principle thinking. We have to think of first principle thinking tells us to take a look at our Earth. We have our elements, we have our atoms, we have inside of our atoms, you have your electrons, you have your positive electrons, you have your neutrons, okay? And how they bounce around, that we can move the atom to create a different wave, and that different wave can give us our 1 and our 0. So that's what we're doing. We're moving these atoms around, as well as we're moving particles around to create this electromagnetic spectrum that we're able to demodulate and modulate. So that's what we're doing here. And Verizon acquired a slither of this cell phone license spectrum back in, let me see, I have the year here. I think it was 2008. And they purchased this for $45,000 billion. So Verizon right now is struggling to sell their licensed spectrum because customers are buying the CBRS, which is another part of the spectrum there. And the CBRS is less expensive. So when you take a look at Verizon, they won the largest FCC C-band auction, securing the 140 to 200 megahertz of the spectrum at $45 billion. That's just for the bidding war in the FCC. All in all, it cost them about $60 billion to acquire this slice of spectrum that is called licensed spectrum. And they're struggling because there's not much a differentiator from that network slice to using what we call CBRS, citizen band radio spectrum. And customers are leaning towards that because there's not too much of a differentiator. The real differentiator is between the licensed spectrum and the CBRS. As you see here, they're both on the same string. It's just that they're running at different gigahertz, I should say. And the CBRS.
Question for you. So it was a while ago. It was probably 8 years ago. I heard it was a former CEO from Verizon. Lowell. I forget his name. But anyhow, this is before,
that was it. It was Lowell. He was the CEO of Verizon.
Okay. Before 5G came out, he was talking about how amazing it's going to be and wonderful, and it's going to change the world. And now you're talking about how much money they spent in buying all of this bandwidth. So it sounds like it's well underutilized, and they've lost a lot of money so far. It's
underutilized. It's in the process of being rolled out still, and it will take years for them to really recognize the revenue on this. But my point to this is we're going to help them.
Yeah, that's what I'm saying is that the things that we do, what you're drawing up here is an opportunity for them to recoup that money with other services if we can help them build those things, right?
Absolutely. My point exactly.
Okay.
So that's what I'm getting at here, guys, is that we want to help Verizon. So they're struggling to recoup the $45 billion because, as I said, they don't have a big enough differentiator. So I am proposing a partnership between Broadcom and Verizon to help become more of a differentiator where customers invest in licensed spectrum, and Verizon can start recognizing the recoup of their investment for licensed spectrum at $45 billion. So what am I proposing here? I propose a strategic relationship with Verizon. Verizon stays within their network domain set. They only know everything about their intellectual property, about packets in transition. They know everything about the network. They manage all the way up to from the device where the device is receiving the data all the way over to the packet core, and then it's a handoff to the application layer. Well, Broadcom sits at the application layer. In fact, if you take a look at the OSI model, Broadcom has invested in all 7 layers of the OSI model. We started off in the physical layer where we have the chips and patents on the silicon chips, so we have a big influence on the physical layer. Okay, with the acquisition of VMware, they have a lot of network capabilities, from VeloCloud to their Vecco, which manages it, to the orchestration engines, and then all the way continuing on up that stack to the application layer is CA and semantic and things that talk to the application layer. So my proposal is about how Broadcom can help Verizon fill the gap of talking to the application layer. Verizon doesn't talk to the application layer. They stop at their network. Broadcom can be that layer where we talk to the application devices, understand their needs, and when they need something different or when they're not getting what they need. And at that point in time, we can go off and tell Verizon through API or machine learning models that this device, this particular device at a very granular level, needs better influence on the network or better capabilities or better SLAs. So that's what my proposal here is, and I'm going to drive into that more in this discussion here. But the concept there is that we are the layer between the application and the network. So Broadcom can help with that, and I'll show you how we're going to do that. We actually have an architecture that will discuss that. So we want to help Verizon be the differentiator, okay? Be the differentiator and help them sell within $45 billion. Again, so far, I'm talking about one of our largest accounts, Verizon, and I haven't even talked about product. I'm trying to get you excited that we're going to do something bigger than just sell products like Atomic and AppNeta. We're going to sell everything to them. Everything that's in our toolkit within Broadcom will be a part of this story, and I'll get to exactly where it all fits within the storyline. But before I do that, let me talk about how one of the things they don't want to do is they don't want to partner with AWS and Azure. You know, I was in a meeting with the executives from AWS that own the telco space and the executives at Verizon, and this was about 4 years ago, and AWS stood up at the end of a 4-hour meeting in the last 10 minutes, and he said, the CTO said, let us take it for you. Let us be your handler for everything application. You can handle all the managed services. Let us help this, build out this layer that talks to the devices, that talks to the applications, and notifies Verizon's when we need better SLAs. And Verizon turned around at that point in time and said, no, they actually turned them down. They saw AWS as a competitor. They see Microsoft Azure as a competitor. Those guys started at the application layer, building out their cloud stack, and they're moving down into the telco space. And the only thing that Verizon has ahead of them is that back in, I think it was 2008, they won the FCC bid for the spectrum. So they own the spectrum. So no matter how much AWS wants a piece of that spectrum, they can only do it with CBRS, and CBRS has its own issues. They can't do it without Verizon. But Verizon saw AWS as a competitor. They don't see Broadcom as a competitor. That's why they're open to having conversations with us, because we're not going to compete with them. Okay? So they struggle with the licensed spectrum, and we have the expertise in the application layer and integrating with applications. So the goal here is to in this engagement is to show Verizon how we can help them dynamically change service level agreements to edge devices at a granular level. And when I say granular level, I mean at a user level, at a device level, at a transaction level. Let's talk about some use cases here. So at a user level, it's when Justin, who's the executive of Broadcom, logs into a system and needs to do a broadcast video to 1,000 people. He should have priority access on the network over Mike Pepe, who's playing Call of Duty and tying up the network. So let's give him priority access because of the user. So we know his credentials, and we can easily, with Atomic, ask, oh, I see Justin's logging in, let's go alert Verizon to upgrade him on the network. Let's give him a better quality of service. Let's put him in a different network slice because he's Justin and he's about to do a video broadcast. So at a point in time, we can upgrade Justin's device. We'll ask what his IMEI number is, where IP address, his user, anything that we need to bring it over to the machine learning models and say, hey, machine learning model, we need to put Justin in the HOV lane. which is the fast lane here in America. How do we do that? And the AI says, well, you need to do X, Y, and Z. And then Atomic can go back and say, okay, time to do X, Y, and Z. Let's move Justin to the HOV lane. So at a very granular level, that's at the user level, at a device level, when the plane on the tarmac is having problems and needs to go into debug mode and turn on more sensors and grab more data and turn on video and have more security, boom, at that point in time, Peppy point in time, at the point in time, we move the device from one network slice to a different network slice. Well, let's take another use case at a transaction level. We're all at a football game. We're wearing our augmented reality glasses. It's the future. And Mike Papa says, hey, I want to be inside of the quarterback's helmet and see what's going on there. I want to be on the field. I want to experience an on-the-field entertainment excitement through my augmented reality glasses. So he pulls out his phone, presses a $5 transaction fee. At that point in time, we kick off an API to tell Atomic, hey, Mike Papa's device, IMEI, IP address, user located here, needs better network services. So at that point in time, his glasses get better services than my glasses because of that transaction. So at a very granular level, we could be that layer for Verizon. I'm going to pause here to see if you guys have questions. Okay, going to continue. I'm short on time here, 5 minutes. Okay, so what does this allow us to do? Well, we're going to be able to help Verizon do something that they're not able to do today. So here are my devices. Here is the electromagnetic spectrum. Inside the spectrum, we have network slices. Here's slice A, here's slice B, here's slice C, okay? We also have quality of service on each one of these slices. So each one of these slices has a different highway lane in itself and has different quality of services. All of this can be changed via APIs. Verizon just doesn't know when to change it, and that's where Broadcom comes in. We're going to build an AI engine that communicates to Verizon's API gateway and tells them the when the device needs to change quality of service, when it needs to change network slicing. And we're going to talk to their API gateway, which will in turn talk to their packet core. So we'll be able to help them at the in-between the application layer and the device layer down to the network. Broadcom will have an AI engine that will help them with the when something is triggered. Think of during the classes that we just recently did, where we were doing the triage and we used Spectrum to monitor the device. And when the hard drive got filled, we kicked off an Atomic solution that went in ahead and triaged the solution. Same concept. We're going to triage it. We're going to tell our service now. We're going to check our CIs, our configuration items. We're going to tell the CMDBs that we're going to make a change on the device. And then we're going to make an API call out to Verizon and say, move this device from one slice to another. So we're going to build out a brain. And every time these transactions go through, every time someone pays at the user level, the transaction level, or the device level, we're going to get a kickback from that. So we're going to build Verizon. Verizon's going to build the device manufacturer or the application manufacturer that's taking advantage of this, and we'll get a kickback. So we'll start off slow, but eventually we'll hit billions of devices on the network, and we'll generate billions of dollars for this concept of moving quality of service. And we'll build for Verizon an OpEx capability, a pay-as-you-go capability to use the network 5G capability to use network services. They can't do that today. Everything they do is static. It's not as pay-as-you-go. When they assign a phone, they assign it to a slice. My phone and Mike Papa's phone work exactly the same if we're standing next to each other on the same carrier. It doesn't have to be like that. If Mike is an emergency medical technician and the planes hit the towers, his devices need to get priority access over Mike Pepe. At that point in time, we can move Mike Papa up to the first responder slice where he has priority access to make a phone call over Mike Pepe. This is what we're driving at with Verizon. My bigger goal, my phase 2, is to build out an engine in front of all of the 3GP architecture with Broadcom and Verizon. So that's my goal here. We only have a couple of minutes left. I don't want to keep everybody on a Friday, so maybe I'll leave this for next time. We can go through the use cases of exactly how we're building this out. But this is what's going on in the background where we're trying to build this out in two methodologies. One from getting the executives in the same room to agree to do this. So we're working on the executives from Broadcom and the executives of Verizon to meet with each other. Those plans are in the works, and they both said yes, they want to meet on this because they're both excited about the same opportunity. In fact, the slides that are up here telling the story aren't even mine. I have passed over the use cases to another department, and they're building this out from a concept level. The second way that we're going to do it is we're going to put ourselves inside of the labs so that we can build out proof of concepts for Verizon and start selling these solutions to Verizon and hoping they can skew them up.
So, Michael,
So with that
one
said,
quick
yes,
question,
yes,
please.
please.
It's banging in the back of my head. All these models that I see in your slides are tech related, like the AI engine, the different capabilities, tools, and stuff like that. Where are you planning to get the business logic? How are you planning to feed that AI engine to like acquire the actual business rules to act upon them?
Great question. From our solutions. For example, I want the NetOps Plus to feed the machine learning models.
Yeah, but you said, let's take the Michael Papa example. He puts his augmented reality lens
Glasses up on the spectrum. Yep.
he made a transaction. That would be pretty dynamic. So you need like something that it's feeding regularly your AI model to like acquire those new rules or those new offers on the market, right?
Yeah, so my AI engine is constantly monitoring the network through its machine learning models. So we're constantly feeding it through NetOps and AppNetter and a bunch of other tools. We're feeding the weather in there to understand how the network is performing. So there's a lot of information that we're feeding to these machine learning models so that when Mike Papa hits a transaction trigger, that trigger goes to Atomic. Atomic says, okay, I see Mike wants to go up on the network. Let's figure this out. Mike, what's your IP address? Mike, what's your username? Mike, what's your IMEI number? Mike, what device? Where are you located? All these questions.
Yes,
Okay.
I have that clear, but my question is before that. How Atomic or your AI engine knows what Michael is doing is worth any effort?
Oh, okay. Great question. I'm sorry. I missed it before. I got it this time. The person that makes the devices, they make the applications that connect to the device. In the case of Mike Papa with the glasses at the football game, who makes those augmented reality glasses? They can signal. They can make an application transaction thing that says these glasses have the ability.
They should send a mark to the
yes,
system.
they send the mark. They send the trigger.
Okay.
Correct.
Got it.
So the customer, like in this case, GE, they create the policy of when they're going to turn on their sensors of LiDAR, video, and sound. They tell me, so they create the trigger. So GE, if they were serving version 5, now they're serving version 6. So now GE has made a better plane engine because not only does it incorporate more sensors that can be handled on the network, but it also incorporates the trigger. So now they sell these engines to Boeing, where they were selling this for $10. They now sell the new version for $22. So the new version has the capability of handling the network. So we work in conjunction with the device manufacturer for these concepts to kick off the trigger. And we don't always have to be there. We basically have to expose an API that says, push this button when you want it.
Framework to any customer can like signal the system to different levels.
Yeah, the device manufacturers will create the signal of, I need to now make this API call because I want better quality of service. Correct.
Yeah, so we need to
and with that, they're incentive because they get to monetize the network. Verizon gets to monetize the network. Broadcom is monetizing the network. Everybody in that story gets to make a profit. It's now a service. And Mike Papa is left holding the bag because he's got to pay for it all.
Got it. Thank you.
Okay, so
I'm filling out a credit card application right now because this is going to be very expensive.
we're going to ask that you mortgage your house, actually, if you don't
There you
mind.
go.
Okay, so guys, I'm going to end it here. I hope this was informative. We can go back next week and we can recap some of this. But next week, we will focus on AI, artificial intelligence, and the foundation of AI. So I'm asking everybody to at least start some of the video of learning AI from the mathematical concepts that will be posted with inside the group chat. Feel free to take what I said here today, think about it, and bring more questions about this so I can review this with you. But I hope you guys, think about this use case over here. Elon Musk is trying to get human consciousness off of this planet, out of this galaxy. So how can we contribute? And the answer is we can all do our own part. Let's start with taking our tools and using AI and making a better world with technology, something that gets us out of bed in the morning, that contributes to this cycle. Again, Elon Musk is not going to get there himself. He's got all these engineers that are building out SpaceX and neurological networks and other things that help him get there. So how do we contribute to this? Well, in this example, we're going to dynamically take his Tesla cars and his rocket ships and everything, and we're going to start moving them around for communication on the spectrum when they need it. These concepts will relay over to his ideas. Sometimes his rockets may need better spectrum, so we can help them move, or his satellites, or his Tesla cars. Think about his Tesla car being upgraded to the first responder network. We used to push a button and the blue lights go on and everybody gets out of your way. What if we push a button now inside the Tesla car and it has priority access on the network so that it can get better communications for its cameras, videos, get the car there faster because he became a first responder. So more than just putting the blue lights on the car and telling everybody to get out of the way, now this one Tesla car at a very granular level has more network capability than other cars. So at a point in time, we can make changes. And that's what we're doing here. We want to help contribute to the bigger problem. So, guys, I want to thank you. I hope this was informative. Let's begin some of the discussion on AI next week. If you any questions before we leave and wrap this up?
Any thoughts about what we're doing?
We need a week to chew it up.
Anyone else?
Great job, Michael.
There's a lot of information to process.
Excellent job, but I need a drink.
I'm with you there, Clever. It's a big ask, it's a big vision, but I hope
Yes.
once we get this off the ground, maybe it was a lot to take in today. Once we get this off the ground, I want everybody's juices to get flowing, that we're all going to be in a think tank together, solving problems. We have a lot of great ideas on the table that we can go and conquer today. And we need your help. We're asking for your help. We're asking for you guys to get excited, and we're asking for your help to build out new solutions that we could take to market with the existing solutions that we have.
Cool. Well,
Yeah.
great job.
I only
Mike.
have one
Thank you.
question to close the call. All the New Yorkers speak faster as you do?
I'm sorry. I do apologize for that, Tony. I knew that was going to be a hinder in the conversation. No, I do apologize for that. Do they all speak as fast as I do? I think I speak faster than the average New Yorker. What do you think, Papa? You're a New
You
Yorker.
started slow, Michael. I can say you started slow.
I get
You
excited,
sounded like
Ronald. I
a-
want to get in there. I
yeah.
want to build this. I'm tired of waiting. Let's go. No more talk. Let's go build
He's
it.
very excited. I'm thinking maybe like some chamomile tea before meeting next week.
Chamomile.
Yeah.
Chamomile is a good.
So you guys
No.
don't want me drinking a full glass of iced coffee for these conversations?
No,
Is that what
no.
you're saying here?
No.
When you started, I felt
we
it
give-
like bourbon. The rasping voice and everything else.
Yes.
I heard
Weekend is
blues up there.
starting. The long weekend is just starting. We need to.
Yes, sir.
would happen if if Michael drank a 5-hour energy drink. That would be
Oh my
crazy.
gosh. The sun, he would beat the sun to its explosion. Yes. he would.
How is
well,
stop
thank you.
Michael from exploding?
Yes.
I get excited. Come on, let's go build. What are we doing? Why are we sitting here? What is there no more talk? Let's do it. Let's go. Let's go.
He needs to finish before the Earth explodes in 1 billion years.
And
Guys,
again,
homework.
we are considering just information. We are considering to move this session for another day and time. I'm analyzing with Michael, and as soon as we find a better time, I will
Saturday
send to you a
morning.
message. Saturday morning is a good feature.
I would like, yeah, Saturday morning gives us more time, so I like that idea. I would like a Monday or early in the week. I don't like a Friday when everybody's checked out and ready to go and get their drink on. I totally understand that. So I'm trying to get the most energetic time so you guys can not really keep up with my but you keep up.
We will
So-
get there. We will get there, man.
I do apologize for my fast talking, but everybody, if you can, for homework this Saturday, use ChatGPT
No,
to
I'm
write
joking.
a song, to write a poem, to write code, to build a Python script. Please go out and use the AI engine, the large language model, and come back on next class and tell us what you did with the large language model and why you thought it was fascinating.
Okay.
Thanks, Mike.
Thank
Thanks,
you, Mike.
everyone.
It was really
guys.
interesting.
You
Have a
Thank
great
you.
weekend,
Good.
guys.
great weekend,
Great
guys.
weekend.
Yep, bye.
Bye.
Bye bye.
Take care.